Hello students, welcome to KK Mishra's tutorials. Today we shall discuss the pseudo force. As the name suggests, it is a fictitious force. It comes into picture when the frame of reference is non-inertial. As we know, Newton's laws of motion is valid only in an inertial frame. But if we observe the body from a non-inertial frame and still want to apply Newton's laws of motion, then we have to apply a force equal to mass times acceleration in the opposite direction of the acceleration. This fictitious force is called the pseudo force, and why its value is ma has been derived in the textbooks. Today we shall discuss it in a simpler way and see whether it is a completely fictitious force. Let us consider a body of mass m which is acted upon by a net force P. If we observe it in an inertial frame y(o(x), then according to Newton's law of motion, it will have an acceleration a equal to p by m. Now let us observe the body from a frame y dash, o dash, x dash, which is moving with the same acceleration and in the same direction. So it is a non-inertial frame. Now the acceleration of the body with respect to this frame A is 0. So what we have, that there is a net force on the body, but it is not producing any acceleration. So Newton's law is not followed. If we want to apply Newton's law in this case, then we will have to apply equal and opposite force on the body to make the net force 0 on the body. Now the net force is 0 and acceleration is 0. So Newton's law is followed and we get the same result as observing from the inertial frame. This equal and opposite force F is called the pseudo force, and its value is equal to mass times acceleration equal to p. So we have the same thing as in the case of inertial frame, p equal to mass times acceleration. But this pseudo force is not totally fictitious. It can be felt by the body or the observer moving with the non-inertial frame, as we have felt it in an accelerating vehicle like a train, a plane, or a bike. So what is this force? This is a force due to inertia and completely depends on the mass of the object. The inertia is a property of the mass. No mass and there will be no inertial force. And this property is stated in the Newton's law, that a body does not want to change its state of uniform motion unless and until it is acted upon by a resultant force. So the pseudo force can also be called an inertial force. Let us see the other cases. Consider a pendulum hanging from the roof of a vehicle that is accelerating with a uniform acceleration A. The string makes an angle alpha with the vertical and then remains in this position. If you analyze it from an inertial frame, that is from the ground, we have tension T in the string and weight of the bob mg, and the bob has an acceleration A. We can apply Newton's law. The component of the force T in the horizontal direction, T sine alpha, equal to ma. But if you analyze it from the vehicle, which is a non-inertial frame, then we do not have the acceleration in the bob. And to apply Newton's law of motion in this non-inertial frame, we have to consider a pseudo force or inertial force F equal to ma in the opposite direction on the bob, and equating the pseudo force F equal to ma to the T sine alpha will give the same result. Again, consider the case of a uniform circular motion when the object is moving in a circle with a constant speed v. As we have observed in the case of a revolving weight with a string around our finger, we have to apply a radially inward force on the object to keep it in the circular motion. It is called the centripetal force. In an inertial frame, this force gives an radially inward acceleration to the object equal to v square by r. So the centripetal force P equal to mv square by r. If we analyze the object from a non-inertial frame which is moving with the object with an acceleration a equal to v square by r in radially inward direction, then the apparent acceleration of the object is 0. But a force is acting on it. To apply the Newton's law in this situation, in this non-inertial frame, we have to consider a pseudo force or inertial force in the radially outward direction, F equal to ma. This pseudo force is also called the centrifugal force. In this frame, we just have to equate the centripetal and centrifugal forces to get F equal to P equal to ma equal to mv square by r. Again, we have the same result. When in a vehicle on a turning road, we all have felt this pseudo force or inertial force, which is called centrifugal force, in the outward direction of the car. So the pseudo force is not a totally fictitious force. It is a force due to the inertia of the body. Hope this discussion is useful. Thank you.